Okay, so we are doing roots of non-perfect squares. How does using the square model help you find the square root of a non-perfect square? So Mindy is making a quilting piece from a square pattern as shown. Each of the two dotted lines is 6 inches. How do you think you could find the approximate length of one side of a square? Okay, square. Remember that a square, the area of a square is side squared. So we need to be able to find the area. Now, as I look at this, I don't know if you see it, but I see 4 triangles. This whole thing right here is worth 6. So from here to here is 3. From here to here is 3. Same thing here, same thing here. So couldn't I find the area of each one of these? These are all the same. They all have the same area because they're the same size. If I remember correctly, the area of a triangle is 1/2 base times height. So I'm going to take 1/2, I'm going to multiply it by 3 and multiply it by 3. I get 1/2 times 9, which is 9/2. Now, that's just for one of them. 9/2 is here. 9/2 is here. This is the area. The area here would be 9/2. And the area here would be 9/2. So if each one of those is 9/2, there are 4 triangles, and I multiply it by 9/2. That's over 1. That would get me 36/2. That would get me 18. So the area of the square we just found is 18. 18 is equal to side squared. Now we talked about if I have an equation that I would take the square root of both sides. Now we don't want the negative version because if we did the negative, we can't find a negative. So the square root of 18 is the length of the side. Okay, so the length of the side is the square root of 18. Okay, if I'm talking about the square root of 18, well, I know the square root of 16 is equal to 4, and I know that the square root of 25 is equal to 5. So the square root of 18 fits in between here. So it's got to be somewhere between 4 and 5. So I'm gonna guesstimate 4.2 because 18 is closer to 16. Okay, look at this. How can you use your knowledge of triangles to find the area of the square? I just did that. Okay, so we're gonna go over to our lesson that's in the book. And we're here, estimate the irrational numbers. Remember, irrational numbers. The number under the radical is not a perfect square. Or perfect cube. There are other ones, but these are the ones that we're going to be using today. So if I look at this, okay, it says the decimal expansion of an irrational number never repeats. Oh, I should be highlighting that, not. Okay, the expansion never repeats nor terminates. Okay, we're going to have to use this symbol right here, which means approximating. We're going to approximate our answers. The answers are never going to be exact. So, if I look at this, And I've been given the square root of 8. The first things I'm going to do is I'm going to look at the two perfect squares that are above and below 8. So the perfect square below 8 is 4. The perfect square above 8 is 9. So the square root of 4 is less than the square root of 8, which is less than the square root of 9. So it's somewhere in between that. This is 2, remember. And this is 3. So it's somewhere between 2 and 3. Now, 8 is closer to 9 than it is to 10, or it's closer to 9 than it is to 4. So that means somewhere around here is going to be the square root of 8. Okay, so let's come here. 83. So I'm going to look on my list of perfect squares, and what is it in between? 81 and 100. Which one is it closer to? It is closer to the square root of 81. Okay, so that means, sorry. So that means it's going to be between 9 and 10. It's close because 83 is closer to 81. I'm going to say somewhere about here. Okay. So we're going to look at this. So the square root of 135 is somewhere between, oops, that's really big, 121 and 144. And this is how I teach my kids how to do it. So the distance between these two. So 135 minus 121 is going to get me 14. The distance between these two, 144 minus 135, is going to get me 9. So it's closer it's going to be closer to the 12. Okay? So it would be 11 point, and it's more than halfway, so I'm going to say approximately 11.7. Okay, so I'm going to do this one. I don't necessarily like how they do it, so I'm going to do it off to the side. So if I'm talking about the square root of 83, as we've already talked about, it's between these two. The distance between these two is 2. The distance between these two is 17. So it's super close to this. So that means it's going to be between 9 and 10. But it's going to be closer to 9 than it is going to be to 10. So it's going to be approximately 9.1 or approximately 9.2. Okay. This one, 106. So I take 106. What is it? What perfect squares is it between? It's between 100 and 121. The distance between 100 and 106 is 6. The distance between here is 15. So that means it's closer to the 100. But unlike the other one, this is 6 and this is 15. So it's not super close to the 100, but it is close. So I'm going to say 10.3. So approximately 10.3. Okay, we're going to do one other one right here. So I'm going to do the square root of 180. So if I was to do that, it's going to be between 169 and 196. So if I look at this, the distance between here is 11, and the distance between here is 16. Ooh, this would be between 13 and 14. Now, do you notice how these numbers are getting closer and closer together? That means that it's almost halfway there. It's not quite halfway there, but it's almost halfway there. So I would say 13.4. I may even say 13.3. So now we're going to look at these, and these are cubed roots. So I'm going to do the same thing. I'm not going to look at theirs. I'm going to look at cubed roots, and we're going to do the exact same thing we did. So what two cubed roots are these in between? What two cubed roots are these two in between? So if I'm talking about this, sorry, I'm going to say it's probably between 216 and 343. So that means it's going to be between undo that. Between 6 and 7. And you should have your list with you at all times. So the distance between this is 104. The distance between this is what? 23? So that means it's super close to the 7. Super close to the 7. It's still going to be 6 point something. And I'm going to either go with 6.8 or 6.9. Okay? This next one. The cubed root of 51. Oops. I want to give myself some room. Cubed root of 51 is going to be between what two cubed roots? Some of you are like, what are the cubes? So 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. Okay, so 51 becomes in between 27 and 64. So then you want to make sure that you know the distance between those. So it's important for you to find the distance. This distance would be 24. This distance would be 13. Okay, so it's going to be closer to the cubed root of 64. So this is in between 3 and 4, but it's closer to the 4, but not like super close, and it's not halfway in between, because if it was halfway in between, these two numbers would be closer together, or they'd be almost the same number. So it's going to be 3 I'm going to say 7 approximately. It would be interesting to find out what the actual answer is. Okay, so here we go. We are not going to be doing that. Okay, so we're going to look at this. Wyatt wants to fence in a square portion of the yard to make a play area for his new puppy. The area covered is 2 square meters. How much fencing should he buy? Okay, so remember that if the area is equal to s squared, that means s squared is equal to 2, so I take the square root, and I get the side is equal to the square root of 2. So we know the side is equal to the square root of 2. Now, the outer part is called the perimeter. So how we find perimeter is 4 times the side. Well, the side is the square root of 2, so I'm going to take 4 and multiply it by the square root of 2. Now, we're not going to do this truncating thing like they have. We're going to do our approximating like we did a minute ago. So, the square root of 2 is between the square root of 1 and the square root of 4. So this is going to be 1 is less than the square root of 2, which is less than 2. So it's going to be, there's 1 away here. There's 2 away here, or no, yeah, there's 2 away there. So it's going to be halfway, almost halfway in between. So I don't know, 1.4, because it's not quite halfway. So we're going to guess that it's 1.4. So when the square root of 2, we're going to approximate as 1.4. So that means, what are you doing? We're going to take, remember, it's 4 times the square root of 2. So I take 4 and I multiply it by 1.4. When I do that, I get 16, 5.6. I'm trying to find the measure. 5.6 meters. Okay. Tobias dropped a tennis ball from the height of 60 feet. The time in seconds takes the ball to fall 60 feet is found by using the expression that. Determine the number of seconds it takes for the ball to fall 60 feet. So we need to do 60, and that's going to be between 49 and 64. So this is 11 away, this is 4 away. So it's going to be somewhere in between that. So 7 is less than the square root of 60, which is less than 8. So I'm going to say it's approximately 7.8. So it says 0.25 right here is multiplied by the square root of 60. So now we're going to take that and multiply it by 7.8. So okay, so that's going to get me 40. That's 16 plus 4, 20. Then this gets me 35. 14 plus 3, 0, 5, 9, 1 with 3 decimal spots. So it's approximately 1.95. And that would be feet. Okay, and we're not going to do that one.